Okay, the next problem, problem 10, says that we're going to buy a house. We want to invest $400 at the end of each month. How much will we have after 7 years if we have an interest rate of 10% and we're compounding monthly? So because we're adding money each time, so we're not just putting one sum of money in and letting it, letting interest happen. We're actually adding to that pile of money every month. Then we need to use an annuity. So we're going to use the TMB calculator again. The total number of payments is going to be 7 times 12. You can just enter in 7 times 12 and hit enter. It'll tell you the number of calculations, which is 84. 10%. We start off with no money. We put in $400 as our payment. We want 12 payments per year, 12 calculations per year. Hit alpha enter on the final value, and it tells you the answer: 48,380.17. The next problem says goods costing $10.88 at the beginning of 1955 cost $233 at the beginning of 1996. Find the average annual inflation rate over this time period. So we know this is exponential growth, and it's just annual. So you can use the same. This is the same formula, right? But since it's annual, the n becomes 1. So we're using basically this formula, which is the same thing. Now at the beginning it's 1088, and it ends up to 3392 after 41 years. So divide both sides by 1088. That gives you 21.5 equals 1 plus r to the 41. Raise both sides to the 1 over 41 power, and you get 1 plus r equals 1.077702. The reason I kept so many decimal places is because it says it wants 1,000th of a percent. So I'm going to have to move the decimal. We'll obviously subtract 1. And I'm going to have 7.770 then to thousandths, and that's percent. Okay, the next problem says $5,000 invested for 9 years, compounded quarterly. So we'll use our finite number of computations formula. And we're investing $5,000. We end up with $7,090.37. 1 plus r over the 4 calculations per year, so n is 4, times 9 years, so it's be 36. Divide both sides by 5,000. That gives you $1.418 equals 1 plus r over 4 to the 36. Raise both sides to the 1 over 36 power. That gives you 1.009749999 equals 1 plus r over 9. Subtract 1 from both sides and multiply both sides by 4. And you get the interest rate, which is 0.038999, so that's about 3.9% if you round to the nearest tenth for me, which is close because these are, all 9s after this pretty much. So there's the rate as a percent. Okay, the next problem says in the 60s, strontium-90 was released into the atmosphere for testing nuclear weapons, got into the bones of people, and the half-life's 27 years. What fraction of it, if it absorbed in 1965, would remain in people's bones in 2005? So that's 40 years later. Okay, so here's our general form, right, for any exponential equation. Now the growth rate is 1/2 in this case, and the exponent would be t over 27 because 27 is a half-life. So when I plug in 27 for t, I should get a 1 here to multiply by 1/2 because half the amount would be remaining. Don't know how much I started with, don't know how much I end up with, but I do know that however much I end up with divided by how much I started with is the ratio of what they were looking for. So they're looking for this right here, the ratio of how much is left. So we just need to solve this when we plug in 40 for t because 40 years go by from 65 to 2005. So do this on your calculator, and that gives you the answer, which is 0.35812, and they want that entered in as a fraction or a decimal, so you could enter this as a fraction if you wanted, but this is fine. All right, next problem. I know we did this problem already, but with just different numbers, so it's just good practice. So we're investing $600 per month, so our payment is going to be $600. And per month in the mutual fund. How much will we have for down payment 7 years after if the annual rate is 9.5%? So 9.5%. 7 years after will be 7 times 12. 12, start off with 0. Payments per year 12, calculations per year 12. Let's go alpha equals, and we should have 71,197. The next problem says an investment grows by 40% over a 10-year period. So you can use this formula. And we want the effective annual, so we're looking at annual, so we can use 1 for n. Now, however much we start with p, we're going to end up with 1.4p because that's a 40% growth. So we can cancel p from both sides of this equation. We know t is 10 years here. So we get 1.4 equals 1 plus r to the 10th power. We can raise both sides to the 1/10th power, and that gives us 1 plus r equals 1.0342. So our r is 3.42, and 2 in my case, but I'm not sure how many decimal places you need here. But that's the percentage you're looking for. The next problem says you have $50,000 5 years from now. What's the minimum amount of money you need to deposit that pays 7% annual interest, compounded annually? So here's the formula once again. So you need $50,000, so you got to put that in the amount that you're going to end up with. We're solving for p here. The rate is 7%, so 0.07, and it's 5 years from now. So we need to think about what n is. Now that's what's changing in this problem. The first time it's annual, so that'd be 1. All right, so we're solving this for p to start, which we can raise both sides to the, I'm sorry, we can actually divide by, this is 1.07 to the 5th power. So we can divide both sides by 1.07 to the 5th power. And that gives us our answer for p. $35,649.31 about. Now I'm going to go back and do this for monthly. So for monthly, I'm going to have to change this 1 to a 12. So we'll change this to a 12 and this to a 12 for 12 calculations per year. So now I'm dividing both sides by this number. Now this is a number I can just do on my calculator, right? 1 plus 0.07 over 12, evaluate that, and then raise it to the 60th power. And then divide both sides by that decimal, whatever that is. That will give you p, which is 35,270.25. Goes right here. And then the last question then is 365 for the number of calculations. So we're going to put 365 here and do the same thing. And in your calculator, you can scroll up and just grab this and just change this number if you want even. But if you do that with 365 right here, you should get $35,064.75. Okay, the next one says the effective annual yield and the continuous growth rate of this. The continuous rate is right here because remember our continuous rate is A equals P e to the RT. So our rate's right there for continuous, which is 19%. And then we need to actually, and I know we've done this before, but we need to convert this then to, like AB to the X or A times 1 plus R, and annual will be over 1 raised to the T. So we need to basically compare this e to the R to this quantity right here. So set 1 plus R equal to e to the 0.19 and solve. So do this in your calculator and subtract 1, and you get a rate of about 0.2092, which is 20.92%. The last problem says an investment pays simple interest in quadruples in 11 years. So we're looking at I'm going to use 1 for M as annual interest rate. And so 11 years, if we start with P, we'll end up with 4P if it quadruples. So the P's cancel. So basically all we need to do is raise both sides to the 1 over 11. And I did that, gave you 1.1343, which should be 13.43%. For some reason that's not accepting that answer. I'm not sure why, but this is the right way to do it. So I'm going to have to just make some extra credit or something.